Hello everyone, welcome back to Online Learning SMPK Penabur. As you know, we are still in the chapter of sound, so today we continue our learn about the Mersenne's law. But before we start, let me to tell you the base competence. Base competence 3.11 analyze the concepts of vibrations, waves, sounds in everyday life including the human auditory system and the sonar system in animals. Objectives. By the end of this lesson, you will be able to know the Mersenne's law, to understand the relationship between frequency, length, density, and the cross-sectional area, and the tension of the string. 3. Calculate the frequency of the string. Alright, let's get started. I have a question for you. Can you play guitar? Or did you ever seen someone play guitar? Yes, you did. But the question is, did you ever notice when strum a guitar on the back near a sound hole? Here, the frequency of the sound is produced lower, or we can say more passive, than when you strum close to the neck of guitar, right here. What do you think? So actually, this question was answered by Mersenne hundreds of years ago. Mersenne was born on September 1588. He was a French theologian, philosopher, mathematician, and music theorist. He made an instrument called the sonometer. We can see from the figure. A sonometer is an instrument used to measure the frequency, the tension, and the density of the strings. So here are the parts of the sonometer. Sonometer consists of a hollow rectangular wooden box of more than 1 meter length, with a hook at one end and a pulley at the other end. One end of the string is affixed at the hook, and the other end passes over the pulley. A wake hanger is attached to the free end of the string. Two adjustable wooden bridges are put over the board, so that the length of the string can be adjusted. So by this instrument, Mersenne discovered a big concept in frequency of the sound. He stated that the frequency of sound is produced by a string of musical instrument depends on 1. The tension of the string, 2. The length of the string, 3. The density of the string, and the cross-section area of the string. Alright, to find out the frequency of the string, we can simplify the Mersenne's law into the formula F equals to 1 over 2L times square root of F over rho times A, where F is the frequency of the string, the unit is Hertz, L is the length of string, the unit is meter, F is the tension applied to the string, the unit is Newton, rho is the density of the string, unit is kilogram per meter cube, and A is the cross-section area of the string, the unit is meter square. So from this formula, we can see the relationship between the length, F, rho, and A to the frequency, right? And we can write like this. From that formula, let's figure out how the tension, the length, the density, and the cross-section area is affected to the frequency. Okay, first the tension of the string. As you can see from that formula is frequency proportional to the square root of F, which means the bigger the density of the string, the higher the frequency, or the smaller the tension of the string, the lower the frequency. Now, the length of the string. Frequency is inversely proportional to the length, which means the longer the string, the lower the frequency, or the shorter the string, the higher the frequency. What about the density of the string? As you can see, frequency is inversely proportional to the square root of rho, which means the bigger of density of the string, the lower the frequency, or the smaller of density of the string, the higher the frequency is produced. Now, the cross-section area of the string. From that formula, frequency is inversely proportional to the square root of A. So that means the bigger of cross-section area of the string, the lower the frequency, or the smaller of cross-sectional area of the string, the higher the frequency is produced. Okay, to understand more about the Mersenne's law, let's solve some problem. Problem 1. A string with a 60 cm long is applied a tension of 5.76 times 10 newtons. The cross-section area of the string is 1 mm squared and density of the string is 10 to the power of 3 kg per meter cube. So the question is, what is the frequency of the string? Okay, from this question, we can see the length is 60 centimeter, which is 0.16 meter, right? And the tension is denoted by F equals to 5.76 times 10 newtons. And the density, rho, is 10 to the power of 3 kg per meter cube. And the cross-section area is denoted by A is 1 millimeter squared, is equal to 10 to the power of minus 6 in meter squared. So the question is frequency. Alright, to find out the frequency, we can use the formula is F equals to 1 over 2L times square root of F over rho times A, right? So we can substitute the number to the formula, 1 over 2 times 0.6 times square root of 5.76 times 10 over 10 to the power of 3 times 10 to the power of minus 6. Okay, we can simplify 1 over 1.2 times square root of 5.76 times 10 over 10 to the power of minus 3. And we can simplify it, again, 1 over 1.2 times 5.76 times 10 to the power of 4. So the square root of 5.76 times 10 to the power of 4, we get 2.4 times 10 to the power of 2. So we can divide, 2.4 divided by 1.2, is 2, right? Times 10 to the power of 2, we get the frequency is 200 Hz. Therefore, the frequency of the string is 200 Hz. Alright, now problem 2. A sonometer string is applied tension of 25 newtons and produce a tone with a frequency of 400 Hz. Determine the frequency of the tone if the tension is decreased to 60 newton. Assume the length of the string, cross-sectional area, and density are constant. Alright, from this question, we can write, 25 newtons is denoted by F1, and 16 is F2, okay? So the frequency 1 is 400 Hz. So the question is, what is the frequency, if the tone is decreases to 16? Alright, to find out, we can use this formula. Because the length, cross-sectional area, and density, are constant, so we only need this part. So we can substitute the number to the formula, 400 over F2 equals to square root of 25 over square root of 16, we get 400 over F2 equals to 5 over 4. 400 divided by 5 is 80, right? So 80 times 4 is 320 Hz. So therefore, the frequency of the tone if the tension is decreased to 60 Newton will be 320 Hz. Alright, I think that's enough for the Mersenne's law. I hope you understand. If you have some question, you can ask your teacher. See you in the next video. God bless you. Bye.